Alrighty, last part. Systems of equations with three variables. Alright, have my three variables. What I need to do, whittle it down into something I've seen. Alright, so to do that, I need to eliminate a variable. So I have to look at this and decide which variable is easiest to eliminate twice. For this, it's going to be z. What you should always look for is a variable with a coefficient 1. Right here, z has a coefficient of -1. That's perfect, all right? Especially because we have +8, +4. So when I go to cancel it out, I only need to multiply by a positive number, and they will automatically cancel. Let's say you don't have one where it's 1's your coefficient. Then what you do, look for pairs, all right? Right here, x would be the second easiest to eliminate because you have 5 and 5, so you just multiply one of these by a negative, they cancel, and then you have to do a little bit of math to solve this. For the y would then be the hardest because you have no matches and no 1 as a coefficient. It wouldn't be too bad, you would just multiply this by 2, and either those two or these two, doesn't matter. We're getting rid of z. Alright? What we do, look, gotta set two of them as a system and eliminate. How do we eliminate z here? Well, we have to get the same coefficient, opposite sign. We're going to multiply by 8. We're going to rewrite that first one. 5x minus 3y plus 8z equal to -59. Multiplying this by 8, we're going to get 72x minus 32y minus 8. Then 8 times 60 is really 8 times 6, 48, add a 0, -8. Right? That's that one, and then I combine them. 5x plus 72x is 77x. 3y minus 32y is -35y. Those cancel. And then that's going to be 20, gives me 39, -539. Right? I now label this and I call it A. Now I have an equation with just two variables and an answer. I need another one. How do I do that? Set another two equal to each other. Again, I have to use this one here because I haven't used it. I used 1 and 2. I have to use 3. What am I going to set it equal to? 2, because I have that coefficient of 1. So when I combine these two, I'm going to multiply this one by 4. That's going to give me 9 times 4. That's going to be 36. X. 4 times 4 minus 16y. -1 times 4, -4z equal, and then again, 60 times 4, 6 times 4, 24, add a 0, -100. Alright. Then I combine. 5 plus 36, that's going to give me 41x. 2 minus 16, that's going to give me -y. Cancel. Equals. To add those together, I'm going to get 287 and it's negative. Alright? Remember, minus minus a minus, a negative minus a minus is just add them together, make it negative. So, now call this equation B. If I put A and B as a system, I get 31x minus y -7. Now I just have a system. You've seen this before, 3, 1, 3, 2, 3, 3. What I want you to do now, pause the video, see if you can solve this, finding either x or y, and you can use elimination or substitution. Give you a hint before you pause it. Looking at this, I would use elimination and I would eliminate y. Alright? Pause the video, solve it, See if you find xy. Okay. All right, so hopefully we're able to find x and y. Like I said, I'm going to use elimination, and I'm going to eliminate y. So what I need to do is find the least common multiple. I decided y was going to be easier, and I'll show you why. What's the least common multiple of 35 and 14? Well, it's 70. How do I know that? You guys remember prime factorization? Got 35. What are its prime factors? 5 and 7, because 5 times 7, 35. I have 14. That's 2 and 7. 2 times 7. Let's say one of those wouldn't have been prime. I just factor it again. Hopefully you guys remember the tree. So now to find the least common multiple, what you do 5 times 7 times 2. But this 7, we already used the 7. So we're good. We don't need to use it a second. Okay? Then you get, that's 10 times 7. They give you 70. That's why their least common multiple is 7. All right? Want to learn more about this? We can talk about this some other time. That's just a quick, wanted to teach you that. So, how do I get that? Multiply this by 2. Multiply this by 5. And I'm going to make that negative. All right? Because I have to make one of them. So, I distribute out my negative 2. 77 times 2, that's going to give me negative 154x plus 70y equal, and then 539 times 2, so that's going to be, let's see, double it, 1,040 minus 2, and 70 positive, right? Want to know how I did that? Come see me some other. All right, now we do 5. So 5 times 41, half of 41, going to be 20 and a half. Shift the decimal, so I get 205x plus 7y. Then half 287 is 1, 4, 3 and a half. 3 and a half. So negative 1435. All right. Again, if you want to know how I'm doing any of this, I'm talking. Or leave a comment below. Comment below, Mr. Oak Schools, just how to do that. All right. This one should be negative. Pay attention. Those cancel. All right. Find those. I'm gonna get 1x. Right. All right. 51x. Find those. I'm gonna get negative negative 357. Divide both sides by 51. 7 at the end, so I'm assuming it's 7. 7. X equals negative 7. Okay? Now found my x. Hopefully you did too. Found it to be negative 7. I then take that and I plug it back into either A or B. Doesn't matter which one. I'm going to go with B because 41 is a smaller number. All right. 41 times negative 7 minus 14y equal to negative 87. 41 times 7, well, that's just 4 times 7, 28, add a 0, 280, add a 7, negative 287 minus 14y is equal to negative 87. Hey, look at that. We add 287 to both sides. They're going to cancel. We're going to get negative 14y equals 0. What times negative 14, 0? Well, y equals 0. All right? Now found 2. I have x is negative 7, y 0. Take both of these answers. I'm going to plug it in any of my original 3 equations. All right? Based on the fact that this coefficient's 1, I'm going back to here. So I plug in my x and my y. So we get 9 times negative 7 minus 4 times 0 minus z equals negative 60. Going to give me negative 63 minus 0 minus z, negative 60. Then you get negative z equals 3, z. Now found my x, my y, my z. This gives me my point of intersection. Again, it's a point, all three planes are intersecting. So, just like this, this three equations graph might look something like this, but they're still only intersecting at this one point right here, right? And that point for this systems of equations goes negative 7, comma 0, comma negative. Circle my answer, and that's that. All right? So hopefully these videos have been helpful. We're all going to do great on the test. If you have any questions, send me an email, leave a comment below. But if you leave a comment, most likely won't see it. Send me an email. All right? Hope this helps.